Okay, this is chapter 4. We're kind of going back to scatter plots and lines of best fit on 4, 5. So I want to go through this, and I'm going to work the TI-84 graphing calculator at the end for those of you who are interested. So I'm going to zoom in so we can see this a little bit better. Sorry. And I'm going to move it sideways so I can get each side, and then we'll go over the TI-84. So on this, a scatter plot shows the relationship between a set of data with two variables. And you know the data with two variables is called bivariant data. So when we look at these scatter plots on a coordinate plane, we can investigate a relationship between the two quantities. So in this case, if you have points going up, you have a positive slope, and they have to be sort of in a straight line. If you have points going down, that's a negative slope, as you know. And if you have points all over the place, in fact, if I was to draw and connect the outside dots, you actually get a zero or no correlation. So you have a positive correlation, points going up, negative correlation, points going down, or a zero or no correlation if the points are all scattered. Okay, so first example, try to get it squared up here. There we go. Determine whether the graph shows a positive, negative, or no correlation. If there is a positive or negative correlation, describe its meaning, which is what we're trying to figure it out. So you can see that's a bunch of points going up. So what does it mean? It means that as the hours is going up, all right, 4 to 8 to 12 to 30 to 40, your wages go up, of course. Okay, the graph shows a positive correlation. As the number of hours working increases, the wages increase. So you have a positive relationship between hours worked and wages. All right, second example. Hopefully I can get this all in. Let's see if I can. It looks like we're close. Okay, we'll pull out a little bit. All right, come on, go. Okay, so the graph on this one shows an average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, negative correlation, or no correlation. If there's a positive or negative correlation, describe its meaning. So again, looking at computer sharing in Maria's school. So as the years go up, you can see the students per computer goes down. So that as a negative correlation is pretty linear. All right, so what it means is that each year Maria's school has more computers, making the students per computer rate smaller. And that's really important. All right, everybody wants that. Let's go move over to the next steps. So let me see if I can zoom in here so it gets a little clearer. So now what we're going to talk about is scatter plots and whether they show a trend in the set of data. When the data points all lie close to a line of fit, best fit, or a trend line can model the trend. So here's your steps. Step 1, make a scatter plot. Determine whether any relationship exists in the data. If it doesn't, then you have no correlation. You have a zero. Draw a line that seems to pass close to most of the points. Use 2 points on the line to make an equation, and then use the line to make predictions. So that's what we're going to do on this real example here. And then I'm going to use the TI-84 graphing calculator and show you how it exactly does it. Okay, the table shows the largest vertical drops of 9 roller coasters in the United States. I love roller coasters. I used to anyway. And the number of years after 1988 that they were opened. Identify the independent and dependent variables. Is there a relationship in the data? If so, predict the vertical drop in a roller coaster built 30 years after 1988. So I'm going to eventually put these in list 1 and list 2 in your graphing calculator. Years since 1988, 1 year, 3, 5, 8. Vertical drop in feet, 151, because back in 1988, and then you got to drop much. 155, then year 5 after 1988, 225, and you can see the drop went all the way up to 306, and then, kind of goes up and down, and then there's one really high here. So if you put the points on a plot, on a graph, you would see these points, and then your vertical line, you're trying to get, when you draw a line of best fit, so many points above the line, the same number of points below the line, and then a couple of them on the line. So The independent variable is the year, okay? Years since 1988. And the dependent variable is your vertical drop, okay? So X and Y. As the number of years increases, the vertical drop of roller coasters also increases. There is a positive correlation between the two variables, which everybody loves, okay? A lot faster drop. So now you draw a line of best fit. No one line will pass through all the data points. Draw a line that passes close to the points a line of fit is shown. There you go. Now the graphing calculator is going to make the line. I'll show you that. So now you write it in slope-intercept form, the equation of a line, using the 2 points, 150 and 300. So 150 and 150 is the proximate values of the data points. So 150 is here, and then 300, 12 up to 300 is there. So here's 2 data points here, okay, approximately 150 and 300. So you're getting approximate values there, okay? So we first find the slope, which is y2 minus y1 over x2 minus x1, or 300 minus 150 over 12 minus 2, or 15. Use 15 and either point to find the y-intercept. So you substitute your point in. X1 is 2, x2 or y1 is 150, and your slope is 15, which we just found. And solve that, and you get 15x plus 120. This means a slope of 15 means that the vertical drops increased an average of 15 feet per year. To predict the vertical drop of a coaster built 30 years ago, substitute 30 for x in the equation. The vertical drop then is 15 times 30 plus 120. You're putting 30 in for x, or 570 feet. Now I'm going to, oops, I didn't move that down and read that. Sorry about that. So now I'm going to stop the video and give you another one if you want to use the TI-84 graphing calculator. So I'm going to show that part separate.